Hello students, welcome to my new video related to the sensitivity analysis of the LPP. In this video, we are talking about what is the impact of the optimal solutions when we add a new variables to the given LPP. So myself is Harish and now we will discuss about the impact of the new variable on the LPP. So far, we have already discussed about the sensitivity analysis, what will of the type 1 and the as well as the type 2 for any LPP that is either maximization or minimization, which is of the form this subjected to ax is equal to b while x is greater than equal to 0. So in the type 1, we have seen that what is the impact on the optimal solution when we change this c. Okay, while in the second type we have seen the impact of this b onto the optimal solutions of the LPP, while the third type is when we add the new variables. New variable means, say if initially x is my nothing but x1, x2 and x3, there is a three-dimensional problem. What will happen if I add the new variable, that is x4, into the given LPP? Is the optimal solution obtained through such variables remain the same, or it will be changes? While the type 4, when we add the new constant to the given problem, that is discussed in the next video. Otherwise the video is super long. So now in this video I'm talking about the type 3, that is addition of the new variables to the given LPP. So what is the meaning of it? So firstly, I just tell you very simple example, that is a type 3. So solve this LPP, that is maximization of 3x1 plus 5x2 subjected to these constraints are there. So I hope you can easily solve this problem with the help of the either graphical method, analytical method, simplex method, dual simplex methods, and so on. You can easily solve it. And once you can solve it, you will get x1 is 0, x2 is 9, and maximum of z is 45 is the required optimal solution. Okay. So now the question is, we just want to add the new variable, that is x3, into the given LPP. Then what will happen? We have to add the new variable x3 into the given LPP, into this LPP whose cost is 7. It means the original is 3x1 plus 5x2. I have to add the new cost 7 to the variable 7x. So that is the meaning of it. 3x1 plus 5x2 is the original one. You have to add the third one, that is a 7x3. And what is the constant? What is the impact of the constant is there. So you have to add the variable cost is my 7, and in the constraints the coefficient of them is 1 and 2. That is, look at that, that is 1 and 2, and look at that, the remaining one are remain same. X1 is less than equal to 4, 3x1 plus 2x2 is less than equal to 18, and then you have to find what is the impact of adding the x3 to this LPP whose cost variable is 3, cost factor is 3, and the constant coefficients are 1 and 2. Okay, so is the optimal solution, that is a 0, 9, is remains same for this problem or not? So this is the main task of this today's topic is that. So that's quite easy. So I think all of you can easily solve it. So I'm not wasting the time to explain how to solve it, because otherwise the video is too lengthy. Okay, so if you still need how to solve it using simplex method, you can see this and you can try to solve it easily with the help of any simplex method. That is entering leaving are there, and then you will solve, then you will get this optimal solution. So my optimal solution is x1 is 0, x2 is 9. Okay, so that is my optimal solution is there. Now what will happen if we add the new variable x3 into this given LPP? So how to add this given LPP is there. So that is basically when the new problem is like this way, that is this. Okay, constants are there. So first thing is that look at the last optimal table. You just consider the last optimal table of the LPP. This is my last optimal table of the LPP. Just consider into the next table. Look at that. Consider the optimal table of the original problem. So remember, this is the original. This is not the optimal table of this. This is the original problem. So what is the original problem is this one. This is my original. So what is the optimal table is? This is my. This is not the optimal. So this is optimal. So that is 9 by 2, 1, 3 by 2, S1, X2 are there. So I just add this one. Okay. So when you add this, that is, this is my new variable. So I have to add this X3 is here, and my objective function is this. Okay. While rest all values, that is 1, 3 by 2, 0, 1, and so on, these all remain the same. That is this one. So how to add this new column are there? So it's quite very simple. So firstly, you have to find the B inverse B. That is the basic matrix B. Okay. So how you find the basic matrix from the, or this is original B. So how you find the B inverse B? So who makes the I in the original table B? So if this is the LPP, who makes the I? That is S1. Second column is S2. Okay. So what is the S1 and S2 value in the final optimal table? This is my S1 and S2. Okay. So now my B inverse is this. Okay. What is the B inverse is? That is inverse of the basic matrix B. Okay. And what is that? This is my basic variables. That's true. That is the basic variables B. Okay. So this is my B inverse B. So everybody know how to calculate how I got it this value 1 3 by 2. That's true. One is by using the elementary row operation, while the other is you have to multiply this B inverse of A1. What is the A1 is coefficient of this X1, that is 1 3. So if you multiply this with the 1 and 3, so you will get this value B. Okay. So now what is that? So my B inverse is 1 0 0 half. Okay. So now the remaining things are very easy. So what is that? You have to calculate the column value this. So what is the X3 column? So what will we do is you have to find, that is a column corresponding to X3. What is that? This is B inverse. What is the column corresponding to X3 is 1 2. Okay. So what is the value of the B inverse? That is 1 0 0 half, and this is 1 2. So when you multiply them, what will happen? This becomes 1. This is 1 by 2 is 1. So this value is 1 and 1. Okay. Now you have to calculate the value of the Zj minus Cj. So what is the, now this is the value of the X1, that is 3. This value are there. This is my 5. This is my 7. These are the slack variables, so there is no roll of inside it. So this is 0. This is my 5. So how to calculate the value of Zj minus C? That's quite easy. This multiply this multiply this, minus of this B. Okay. So this is 0 5 minus 7. This is minus 2 B. Okay. So clearly seen that this is not the optimal table, because Zj minus C is not be a positive B. So you have to enter this. What is the leaving one is this, because the minimum ratio is 4:1. That is 9:1. That is 4 is minimum. So this is my and leaving one. So what is the new one is? That is my X3, and now this is X2B. Okay. So how you calculate all those values? Firstly, this is X3. That's quite easy. This becomes the I always. X2, that is the second column. Okay. Zj minus C is always be a 0. Divided this by the pivot element, that is 1. This, and this B. Okay. Now you have to calculate the remaining values. So that is with respect to this. So that is R2 minus R1, and this is 2 times of this. Okay. So if you take 2 times of this is 13 by 2, this is 0, this is 0, this is 2, this is 5 by 2, this is my 53. Okay. So this is my half. If you subtract this is 0, this is minus 1, this is plus half, this is my 5. Fine. So what will happen be? So look at that. Now since this is my Zj minus Cj, so Zj minus Cj is greater than 0 for all. So now the optimal solution reach 1. So what is the optimal solution is? So you can easily see that what is the optimal solution be. So optimal solution becomes, what is x1 is 0, x2 is my, that is 5, x3 is my 4, and the value of z is my 53. So this is the impact of adding the new variables x3 onto the optimal solution. So it means the original optimal solutions is changed when we add the new variable x3. Okay, and the new objective values becomes, firstly one is 45, so when you add the new variable x3, the objective values increases by 53 minus 45. Okay, so this is the way how to calculate the impact of adding the new variables into the LPP. So I just recall this, that's very simple. What is the steps are there? Okay, so always remember this is one of the simplest type is there. Firstly, formulate the optimal table of the original LPP. Always remember, this is always for the original LPP, not for the any LPP. Okay, what is the second step is calculate B inverse B. Okay, so B inverse from the original LPP, original optimal table of the LPP. This is always remember, this is the optimal original. Okay, so once you add, calculate this, then calculate columns corresponding to the adding variable B. Okay, so you have to add the column in the optimal table. So how you calculate them? This is B inverse of whatever the variable is there. Okay, so this is B inverse, this is your B inverse, and this is the column entry. So once you get, then this is, and the last one is calculate Zj minus Cj. So if it is greater than 0, then optimal. Otherwise, if it is not be there, then you have to enter this one, leaving this, and find the optimal solution. So look at that. Says few question are practice for you, but I just give you a hint how to solve this problem. Okay, so what is that? This is the maximization problem. Okay, and all the constants are less than or equal to type. So it means either the constants are this or this way, and the optimal table is given below. So this is the optimal table. Look at the, what is that? This is the x1, x2, x3, s1 and a2. A2 is the artificial variable. S1 is the slack variable in the first constraint. A2 is the second artificial variable in the second constraint. What is the meaning? That is, the first constraint is the less than sign, second constraint is the equality sign. Okay, and there are the three variables x1, x2 and x3 are there, and s1, s2 are there. So this is the optimal table because Zj minus Cj is greater than 0. So what is that? From this table, what do you calculate that? X1 is nothing but 9 by 5. Okay. X2 is nothing but 8 by 5. X3 is my 0. Okay, and value of Z is my 141 by 5. So Z is 141 by 5. So now the question is, you have to add the new variable, that is x4, which is non-negativity. That's most important thing is there, whose cost factor is 30, is assigned to the given objective function. It means the new objective function is something like 30x4. And suppose the coefficient of the x4 in the two constraints are 5 and 7. So it means you have to firstly formulate the problem. Okay, so what is that? You have to find, that is maximization of Z is something x1 plus, because here LPP is not given, so it means you have to find firstly this and so on, plus 3x3 plus 30x4. Okay, subjective to constant, these are the previous constant, plus the first one is, that is 5, so that is 5x4 is less than equal to something, while in the second case this is 7x4, this is the equality sign, it is always be given. Okay, so look at that, this and this, so you have to find the value of x3, x1, x2 if needed be. So what is that? So look at that. So what will we do is, you have to construct this table x1, x2, x3. This is already given to you. Okay, this is already given to you, and you have to add the new variable, that is x4 here. Okay, so this value is previously known to you, this is previously known to you, all our value are known to you. Okay, this is solution, this is also known to you. So but the thing is how to find x4. So firstly you have to find the B inverse B. Okay, so what is the B inverse? So look at that. Here the problem is the two variable, two constraints. So what is the first one? That is S1, and the second is the A2. Formulate I B2 B inverse, sorry. So that is the B inverse will be, what is that? This is my B inverse. Okay, so what is that? This is 2 by 5, 1 by 5. This is 2 by 5, 1 by 5, then minus 1 by 5 and 2 by 5. Now what is that? How you find this value? So that is column corresponding to x4, that is 2 by 5, 1 by 5, minus 1 by 5, 2 by 5, and what is the column corresponding to x4 is, look at that, what is the column corresponding to x4 is 5, 7. Okay, so 5, 7. So that is, you get A or B is there, and that value of A is B is here. Okay, and what is the value of this? So since this is the optimal table, so there is no change in these values are there, so that is 0, 0. Okay, this is 3 by 5. Okay, then is 29 and m minus 2 by 5. And how to calculate this value is, so oh sorry, what is the previous value is x2 x1. Okay, so what is the new values are there? There is no change in the previous value. So what is the previous value of x1, x2 and x3? The previous value of x1 is 5, so this number is my 5. X2 is 12, x3 is still missing. Okay, but there is no need of x3 in this given problem because x2 is and this, so this multiply this multiply this, and what is the value of this? 5, 12, this is still unknown, this is 30. Okay, and you will able to calculate the value of this number. Okay, so if all zj minus cj is greater than equal to 0, then it's optimal, otherwise not. Okay, but still if student wants to calculate this value, then again it's quite easy to calculate them, because how to calculate that? Look at the previous value of x3 is minus 1 by 5 and plus 7 by 5. Okay, so if I just rub this value, so this is my, what is that, minus 1 by 5 and plus 7 by. Okay, so how to calculate this value? So if I just rub this number, so what is that? This 3 by 5 is nothing but zj minus cj is nothing but 3 by 5. So how you calculate that? This is 12 into this plus 35 upon 5 minus this is called as a c3 because it is unknown, is 3 by 5. So after solving you will get c3. Okay, so this is the way to calculate the value of this. Okay, so once you solve it, the answers of this, what is the impact? Is there any impact of that? So if x1 is changed, then there is an impact, otherwise not. So what is the answer of this problem is, so I just write the answer of this problem here. So the answers is x1 is 0, x2 is 25 by 19, x3 is 0, and x4 is 91 by 9, and the value of z after solving you will get 3, 0. Okay, so it means, what is the statement is, discuss the impact of these new variables. So is there any impact of these new variables? Yes, because the original value of z is 141 by 5 while the new value is 30, 30. So therefore there is an impact or effect by adding a new variable. Okay, students, so quickly look at on the second problem. That's very easy. That's a 4 variables are there and some constants are there. When you try to solve this problem with any simplex method or analytical method or the dual simplex also, you will get these answers are there. So you can easily try to solve it. This x2 is my 0, x3 is again 0, x4 is my 5 by 90, and the value of z comes to be this. Okay. So now what's the second part is, discuss the impact of adding the new negative variable x5 in the optimal solutions. It is given that the coefficient of x5 in the constraints are 275. So it means there is a new problem whose constants are this plus 2x5. This is the first constant. This is the previous one plus 7x5 in the second case plus 3x35 is less than equal to this. And the cost component with x5 is 7. So it means the objective function will be plus 5x5. Okay, so again you will try to solve this problem. You need a B inverse. So once you solve this by the simplex method, what is the B inverse? Here you add the S1, here you add S2, here you add S3, and these are the starting variables of the simplex table. So this is my B inverse. So when you multiply B inverse by this column, because this is the column corresponding to x5, then you will get the required answers. And what is the answer of this is optimality is not changes. So this is the example I just gave to you, this in which optimal does not changes. What is the meaning of that? It means once you add this and after that calculate zj minus cj, and in the first table it will be greater than equal to 0. It means the optimal answer of this problem is this, and while for this problem is also be this one. So that's the meaning of the optimal not changes. So if there is still any doubt, you can ask me at any time by sending an email or in the comment section. So thank you for listening and best of luck for the students.